Find the zeros of f of x equals 3x cubed plus 9x squared plus x plus 3. The complete factorization theorem guarantees that we can factor any polynomial of degree greater than or equal to 1 if we can find the zeros of the polynomials, assuming that we use complex numbers. First, we find the zeros of this polynomial any way we can. Notice that by grouping the first two terms, we can factor out 3x squared. And so p of x is 3x squared times the quantity x plus 3. Recall that if we factor out 3x squared, then we take 3x cubed divided by 3x squared to end up with whatever inside the parentheses. The same thing. 9x squared divided by 3x squared is 3. And then we group the last two terms, x plus 3. We now have two big terms, and they share x plus 3 in common, so we factor out x plus 3. What is left from the first term is 3x squared, and what is left from the second term is 1. From reading this factor form, we see that x equals negative 3. The second factor is called an irreducible quadratic. We won't be able to factor this further unless we use complex numbers. This might be an odd new request, but it is recommended that we also factor out 3 to end up with 3 times x squared plus 1/3. 3x squared divided by 3 is x squared, and 1 divided by 3 is 1/3. And so this is 3 times x plus 3 times x squared plus 1/3. There is only one real zeros here. We still need to find two other zeros. In this case, the other two zeros will be complex. Set x squared plus 1/3 equals 0. We have x squared equals negative 1/3, and so x equals plus or minus the square root of negative 1/3. We will rewrite this as plus or minus the square root of negative 1 times 1/3. The square root of negative 1 times 1/3 is the square root of negative 1 times the square root of 1/3. The square root of negative 1 by definition is I. The square root of 1/3 is the square root of 1 over the square root of 3. And so this is I times 1 over root 3. To not have the radical in the denominator, we would multiply a well-chosen one to rationalize the denominator, root 3 over root 3. This will give us I times root 3 over 3, or I root 3 over 3. And this is x. And so the three zeros are x equals negative 3, x equals negative I root 3 over 3, and x equals plus I root 3 over 3. The complete factorization theorem states that we can write the polynomial as it was 3x plus 3 times x squared plus 1/3, but we also found the other two complex zeros, and they are x minus I root 3 over 3 times x plus I root 3 over 3. If we did not factor out the 3, and so we end up with x squared equals negative 1/3, we would lose this factor 3. And so We will not end up with 3x cubed if we were to multiply these out without the factor 3. And again, it is recommended that when we find the complex solutions, we will simply factor out the coefficient in front of the x squared.